this is an example of a couple of these. So as we work through these, when we solve a proportion, okay, our process is to do what? Cross multiply and solve, right? When we cross multiply, if you have anything that has a plus or a minus in it, we have to put that expression in parentheses. So if I have an x minus 1, like I have here, I don't need to do it with the 2x because there's no plus or minus sign here, okay? There is no distributing that's going to take place with 2x. But I have to do it with the x minus 5. And especially for one like this, what I would recommend doing is showing what's going on here, okay? Cross multiplying, and when I cross multiply and I write these two things out, now I write it as an equation. This equals this, okay? And a question that I get a lot is, does it matter which one I do first? Can I do this first? I could put the 6x over here and the 5 times x minus 1 over here. So it doesn't matter which side is which, okay? As long as you set them equal to each other. And here's why the parentheses are such a big deal, is because I now have to take that 5 and distribute it. If I don't put parentheses around the x minus 1, I'm going to forget to distribute here, and that's a big deal. I'm going to get a completely different answer. And so we got to be really, really careful about that. And then I can subtract 5x, and I get x equals negative 5. Hey, other thing I wanted to mention here too, is it okay to get a negative answer? Sometimes we get a negative answer and we're like, oh, wait, something's right. I must have done something wrong. Is it okay to get a negative answer? Yeah, okay. Negative numbers are just part of life, right? We don't want to have like a negative bank account, right? That's not a good situation. But negative numbers are a part of life, okay? And so that's why we have negatives, is because it kind of determines the situation. And negative is okay here. If I were to check my answer, okay, just to kind of show you, that this makes sense. Negative 5 minus 1 would be negative 6. So this would be negative 6 over 3. The other side is 2 times negative 5, which is negative 10. And this is negative 10 over 5. Okay, all we're trying to determine is, are these two equal? You can always check your answer, guys, okay? What do I get if I take negative 6 divided by 3? Negative 2, okay? Negative 10 divided by 5? Negative 2, okay? Both of them equal negative 2, so those two sides are equal. We got two equal parts, okay? So it's okay if you get a negative answer. It's also okay if I get a decimal or a fraction. Sometimes we freak out when we get decimals and fractions. It's okay, okay? Decimals and fractions are also a part of life. We're going to get decimals and fractions sometimes. Okay, try the one on the right. See if you can cross multiply and simplify that one and solve it. Solve for x. The best way to leave our answer here is you are going to get a fraction or a decimal. I'll just tell you that. And the best way to leave it probably would be the fraction, because fractions are going to be a better way to express our answer. That way we stay away from like repeating decimals and things like that. Okay, so here's kind of the process. Okay, how do we feel about that? Everybody get negative 9/2 or negative 4.5? Okay, and so here's another situation where, can we have a negative answer? Yeah. Can we have an answer that's a fraction or a decimal? Absolutely. Okay, so we're going to get some weird looking answers at times. That doesn't mean we've done something wrong. Just means we need to double check our answer. Thank you. And once again, it doesn't matter which one's left and right. Sometimes when we get to this point here, 18x plus 27 equals 12x, it's like, what do? You have a couple of options. You could subtract 18x like I did. You could also subtract 12x and then move 27 over here. Regardless of the order that you do it in, you should still arrive at the same answer. Okay. Questions on that one? Everybody good with the process there, the work there? Okay. Those are all things that we've done in Algebra 1, okay? It's been a little while, but we're going to continue seeing problems like that. So just kind of starting off with that today, because that's going to be something that we're going to spend some time with this week especially. And we did a little bit last week. Okay, today the big concept is what we call the triangle proportionality theorem. If I have a triangle and I draw a line through the middle of that triangle, if TU is parallel to QS, and we see that to be true here, TU and QS are parallel, then it's going to divide the two sides proportionally, okay? And what we mean by that is we don't know for sure. We don't know for sure if like QT and TR are the same length, okay? We're not saying that T is right in the middle of this. It's not the midpoint. Last chapter we talked about the mid-segment. This is not necessarily the mid-segment. It could be, but it's probably not going to be. We're saying that it's going to divide it proportionally, okay? So for instance, if I say this is 2 and this is 6, and I say that this piece here is 4, then to get to UR, because it's proportionally, that means it's the same scale factor. So to get from 2 to 6, how much bigger is 6 than 2? 3 times. We're talking about scale factors here. What you can't do is you can't say, oh, I'm going to add 4 to get here, because adding and subtracting is not proportionality. Okay? Adding and subtracting is the same scale factor, multiplying or dividing. So to get from 2 to 6, I multiply by 3. So that tells me that UR must be 12, because they're both 3 times longer. They're separating that side proportionally into the same ratio. Okay? So that's one thing you got to be really careful of. If I did 2 over 6, that would be in the same ratio as 4 to 12. And you could either reduce it, or you could cross multiply and prove that they're the same, but these two are in the same ratio as one another. Hey, you could also go the other way. If I know these two sides are in proportion to one another, then that proves that TU and QS are parallel. So in this case, they don't tell me that TU and QS are parallel right away, but we're going to prove that they're parallel. Okay? And I keep talking about that word proving because you would say something like, because these sides are proportional, then that means those lines are parallel. Okay? So what do we know first in order to prove what we need to get to? Okay? So it's the same idea, just a matter of what we're given to get there. Okay, so let's look at a couple of examples here. On this first one, it says find the length of RQ. So it may not always have the length labeled. So in this case, I have an X at RQ or QR. I'm just going to put an X there, and you can put whatever letter you want to, but X is probably our most common letter. And all I'm going to do is set up a proportion here. As long as these two are parallel, that's the first thing we got to pay attention to today. As long as these two are parallel, then it's separating these sides proportionally. So when I set up my proportion here, I'm going to say X is to 9. So I'm going to compare these two sides as 4 is to 6. And it's not quite as simple as the one I gave you a few minutes ago where it was like 3 times bigger or 2 times bigger. But we set up a proportion. And this is where it's pretty similar to what we did last week. Once we have the proportion set up, we're going to do cross multiplying. 6x equals 36 Divide by 6, x equals 6. And that would be my little piece right there. The first thing I like to do on all these problems today is label the piece that we're trying to find. And I'll show you an example here in a little bit where it can get a little bit tricky on what they're asking for. But in this one, they're asking me to find zy. Okay? Zy is x. Okay? So I'm going to put an x in. I just use x all the time. The two sides that are on this, or the two pieces that are on the same side. These are the two pieces that are on the same side. And it really doesn't matter what you start with. If you want to start with the one that has both lengths to it, you could go 4:10 as 5:x. One thing, like we talked about last week, we want to make sure that we stay in the same order. If I go 4 to 10, I'm kind of going left to right here. Then I would go left to right here as well. So I'm trying to stay proportionally as I go through this. And once again, we can cross multiply and solve. And then we take 50 divided by 4. And that gives us 12 and a half. Okay? Don't think, oh no, I must have done something wrong. Okay? I want you to get out of that mindset, because that doesn't mean we've done something wrong. Decimals are going to happen. We're going to see decimals a lot throughout the rest of this semester. So we've got to be okay with getting a decimal answer. I know we love it a lot better when we get a nice whole number for an answer, but life's not in whole numbers, right? If you go make change at the store, when you buy something, they're not going to always just give you a dollar bill back, right? They're going to give you a dollar bill and some change back if you have more than a dollar in change or less than a dollar in change. So it's a pretty common thing to work in less than nice whole numbers. Okay, once again, YZ. I just insert an X. And there's a lot of different ways to set these up. There's more than one correct way to do it. If you wanted to go this direction, that's okay, as long as I stay going right to left. I always like to move left to right, because that's the way we do most things, read a book or whatever. So we're going to go 35 to 44 equals x to 36. And we're just setting up a proportion today, okay? And we're going to see this a lot on the test on Friday as well. We saw proportions last week. We're going to see proportions today. That's going to be a pretty common theme for the rest of this chapter. And here's what I'll tell you. Like, you don't have to write out everything here. If you simply want to take 36 times 35 and then divide it by 44, I would kind of like to see this at the very least. Like, especially on a test, so I can see what proportion you set up to see if you set it up correctly. But then you can probably just use your calculator from here. 36 times 35 divided by 44. Hey, now, here's what happens in this scenario. What is 36 times 35? Okay? And if I take 1,260 and divide it by 44, what do I get? The repeating decimal, okay? We do not want the repeating decimal today, okay? If you try to put the repeating decimal down as an answer, big ideas won't count it right. I probably won't count it right on your test on Friday, okay? We want the exact answer, and the exact answer is going to be your fraction. So, if you have a calculator, let's get it out. And we talked about this a little bit last week. Most of your calculators will do the reduced work here. If your calculator changes it to a decimal, you have a button on most of your calculators that'll change that decimal back into a fraction. If you don't know where that's at, let me know and I can show you, okay? Anybody need help finding that on their calculator? Yeah? Alright, a lot of your calculators are changing it to a mixed fraction. I don't really have a problem with the mixed fraction, but in most cases, it would be better to just leave it as a improper fraction, which means the number on top is bigger than the number on bottom, which is 315 over 11. That would probably be the best way to leave it, is that, okay? We don't want the 28.6 repeating. And if it was just like 0.5, then I'm not as upset with the decimal, but with the repeating decimal, we don't want to write like 28.6, or where do I round it at? Or I know in past years you might have written like 28.6 repeating and put a bar over the 6. There's not really anything wrong with that either, as long as you show it has a 6 above it and it's repeating. But once again, I still feel like the fraction is the best way to go, okay? If you have issues with your calculator, know how to use that, because that'll be a big help for you on your test on Friday. So if you need some help with that, don't hesitate to ask. I'll be glad to show you. Okay, same thing here. This is the triangle proportionality in its converse, using it in some different ways. What I would do here, if you don't already have a picture drawn, then I would draw one. This one kind of already has the picture drawn, but I'm going to redraw it just to kind of bring it out here by itself. We have A, B, C, D, and E. It's kind of hard to see all of that within the picture there. Okay, they tell us that BA is 33. They tell us that CB is 27. They tell us CD is 44. And they tell us that DE is 25. We want to know, are BD and AE parallel? Okay, that's the question that's being asked. Explain why the shelf is not parallel to the floor. Okay, so in this case, they're saying it's not parallel, and you can kind of see that it's kind of leaning a little bit. Okay, and in this case, that's kind of the way it's designed, so you get a better look at the shoe. You can kind of see the whole thing better. But to show why, you're going to set up a proportion. And right away here, you could probably almost tell from the numbers that you're given that this is not going to work. Because 27 to 33, 27 is less than 33. Here, 44 is bigger than 25. So that kind of right there is like the dead giveaway. But as far as some work here, something to show me you know what you're talking about, we would say no, they're not parallel, because you could reduce them both, okay? Or you could just do straight cross multiplying. So 44 times 33, and then 27 times 25. What would 44 times 33 give me? Okay? And then we want to see if it equals 27 times 25, which is what? Okay. So they're not even close. So we would just say something like that. Because these two are not equal, that means that BD is not parallel to AE. So there's your parallel symbol with the slash through. It's just an easy way of saying not parallel to. You can actually use the words not parallel to if you want to, but that is kind of a quick and easy way of saying not parallel. Okay, and this one, same thing. Determine if PS and QR are parallel. So we're going to go 90 to 50, 72 to 40. Once again, try to keep it in order. Left to right, left to right. set up the proportion correctly. 90 times 40, 3,600. That one shouldn't be too bad to do. 9 times 4 is 36, add 2 zeros. 72 times 50. Okay. So we would say yes, PS is parallel to QR. And that's really enough proof, right? This right here, because these two are equal, that allows me to say yes. If you just said yes or no without any of this work over here, I would want to know, how did you get there? Why are you saying yes? Okay? You got to have something to back it up. It doesn't have to be words. It could be work, right? Which we have here. Okay, here's another theorem. We call this one the three parallel lines theorem. Okay? And just like you would think, we have three lines that are parallel. So we got U, V, W, X, Y, Z are all parallel to one another. Okay? If we have three lines that are parallel. Now, what we're saying here is they're not separating these by the same length. So I'm not saying that these two have the same length here, but they're going to separate them proportionally, because L and M may not be parallel. Okay? And in most cases, they probably won't be parallel. It's not parallel lines transversal like we saw way back when. But what they're going to do is they're going to separate it proportionally. So the three lines are going to separate those two transversal lines proportionally. So UW is the same to WY as VX is to XC. Okay? So let's look at an example down here. We want to find the distance of HF. Now here's the part where you got to be really, really careful. Pay attention to what it is that we're trying to find. And this looks just like the problems that we did just a second ago. The only difference is it doesn't necessarily form a triangle like we saw on the last couple of problems. You got these streets, and the streets are not laid out nice and parallel to one another. Main Street, Second Street, and South Main are all parallel. But what we're looking at here is the relationship that's going on here. Okay? So as we look at this, what we're going to do, and I know this one does not have parallel lines. How do we know these lines are parallel without the marking being on them? Let's talk about that first.
Congruent angles.
Yeah. We got corresponding angles here, right? Because all three of these angles are corresponding, that means all three of these lines are parallel. So they don't just come right out and tell me that these lines are parallel, but we can quickly conclude that, right? So knowing what we know, how can we get to where we need to be? And then we're going to set up a proportion. 120 is to X as 150 is to 300. Okay, now there's a really easy way to do this problem, and you can do this sometimes if it's a really easy scale factor. Other times you'll probably have to do cross multiply and solve. How much bigger is 300 than 150? 2 times bigger, right? So to get from 120 to here, all I would really have to do is double it, right? If you recognize that. Some of you may not be able to recognize that 300 is 2 times bigger. So then what you could also do is you could cross multiply, and that's okay too, okay? 120 times 300 divided by 150. Either way we do it, it should give me 240. Okay, but here's what I was telling you. Pay attention to what it's asking us to find. It's asking us to find HF. HF is this whole thing right here. So don't just say my answer is 240, because it's not asking me for GH, it's asking me for FH. So what do we got to do to find FH now? Add them up, okay? So now we're going to go 120 plus 240. So that'd be 360. And probably should label it yards, since we got yards on there. Not every one of these is going to have a label, but that one's kind of a story problem. So, Okay, once again, we see corresponding angles are all congruent, so we know all three of these lines are parallel. So we're going to say 40 is to 16 as 30 is to x. So on this one, I'm happening to go right to left. Okay, I'm just switching up the order for you. If you wanted to go 16 to 40, that's okay. Then you would say x goes to 30. We're going left to right or right to left, as long as we stay consistent with how we do it. And now we can cross multiply. This is not a real easy scale factor, 16 to 40, so you're probably going to want to cross multiply here. We get 480 divided by 40, and so that should give us 12. And this time it's asking me for BD, and BD is this little piece right here, which is what we just found. So BD is 12. So make sure that you have found what they are asking you to find. If not, use it to find what you're needing. Okay, this one up here, not much different. Once again, we see three 90-degree angles here, so that tells us these three lines are parallel. And once again, we're just setting up a proportion. 16 goes to x as 15 goes to 18. Cross multiply and solve. There's lots of different ways to set these proportions up. If you set it up a different way and get the same answer, then that's okay. But there are also wrong ways to set up the proportion. If you go left to right and then right back to left, that would be an incorrect way of setting it up. So we got to be really, really careful. Okay, on this one, what do we get for an answer on this one? What'd you get, Ethan? Okay, what is it?
32 over 25.
32 over 25, okay. Let's see here. It doesn't seem quite right. 32 over 20, how much? 96 over 5? That sounds,
I might have said it wrong.
okay. 96 over 5. This would be one where 19.2 would be acceptable. I'm okay with decimals as long as we call that a terminating decimal, where it stops at 0.2. It doesn't keep going. It's not repeating, right? So if you have a decimal that is terminating, that stops, then decimals aren't a bad way to leave your answer. Really, it's when we have repeating decimals. So either one of those would be acceptable answers there. All right, last group of problems here. We call this the triangle angle bisector theorem. We have a bisector of this angle. We know these two angles are congruent. If these two angles are congruent, then it's going to bisect this proportionally, okay? So that means AC to BC would be proportional to AD to BD, okay? So let's look at an example here. We know these two angles are congruent. So the first proportion or ratio that we're going to set up is we're going to say 7 goes to 13. We're going to compare the two sides of the triangle, 7 to 13. Now here's the part that's a little bit tricky, okay? And this is probably the part that gets missed more than anything else. 15 is the length of the whole thing. If I told you that RS was 5, or let's say 10 because it's longer. Let's say this is 10, what would QR have to be? It'd be 5, right? If this is 10, this would have to be 5 because these two have to add up to be 15. So I would just take 15 minus this and give me this. Well, I don't know what x is. X is a value, it's a variable. So we're going to do 15 minus x to get QR. So in here, we're going to write 15 minus x. Whatever x is, we got to take 15 minus that. Hey, when I set up my proportion here then, we're going to put 15 minus x over x. We're going to compare the lengths of those two smaller pieces. So we're not putting 15 into our proportion. We're putting this piece to this piece. Would it be okay if I wrote x minus 15? No, because subtraction is not commutative, which means 7 minus 8 and 8 minus 7 give me two different answers. If I did addition with those two, that's okay. But order matters when we do subtraction. So 15 minus x is the way that has to be written. And once again, as we've talked about, because it has a minus sign in it, we've got to put parentheses around it. Okay, extremely important. I know some of you guys don't like to take the time to write things out, but for most of you, it's worth the time, okay? If you don't take the time to write it out, you're probably going to make mistakes somewhere along the way, okay? So I highly encourage you to write it out step by step here. We're going to distribute the 13. We're going to add 13x over here. And then 195 divided by 20. Okay, once again, it's not a repeating decimal, it's terminating, so you could do 9.75, or what's the fraction if I did 195 over 20? How much? 39 over 4, okay. Either one of those would be okay. Okay, this one here is a whole lot easier. Because we don't know the entire length, we're just going to go 24 goes to 48 as 14 goes to x. Here's another one of those where this is 2 times bigger than this, so I could find x really, really quickly by just doubling it, okay? If you recognize that. That may not be something that a lot of you may recognize, but either way, if you cross multiply it, you'd still end up with